Hi, this video is for 2016 AP Calculus AB exam question number 3. So it's a non-calculator question. This is a very common question that tests your understanding of the fundamental theorem of calculus. So let's see what we have here. We have this graph. It's a piecewise linear function, so it consists of lines, line segments I should say, and function g. So please note, this is function f. What you see here. Function g is defined as g of x is equal to the integral from 2 to x of f of t dt. So we have an integral function. And all the questions that are going to follow are going to ask you about function g. So please be very careful. A. Does g have a relative minimum, a relative maximum, or neither at x equals 10? Justify your answer. So I'm going to take a look at the graph first and I'm going to explain. We are looking at the minimum or maximum, so we need to analyze the derivative of g. Derivative of g here is going to equal to f of x. So we can write here that part A, g prime of x is going to equal to f of x. Right? So what we want to see, if we want to have a relative minimum or relative maximum, we want to see a sign change. So the question now is, if this is what we have, is there a sign change for g prime or f of x at that point? No. It's negative here, it's still negative here. It is 0, the derivative g prime is 0 at 10, but there is no sign change. Therefore, there is no minimum or maximum. So we can write at x equals 10, g of x does not have a relative minimum or a relative maximum. So that's just the answer. We need to justify it. So to justify it, because g prime of x does not change sign. And that's it. Let's take a look at part B. Does the graph of g has a point of inflection at x equals 4? So point of inflection, that means we're working with the second derivative. So we need to look at g double prime. That's the first thing we need to do. Part B. So g double prime of x is f prime of x. We differentiate both sides of this expression here. So we want to see if f prime changes sign at 4. Now let's see, that would be the slope of f. So the derivative of f is positive to the right, to the left of 4, and it's negative to the right of 4. It changes sign. So yes, there is a point of inflection there. So we can write that g of x has a point of inflection at x equals 4 because, remember, there is a justify your answer part, because g double prime of x changes sign at x equals 4. Now it is very important for these both questions A and B that before you can rely on g prime and you can rely on g double prime, you show the relationship that you have between g double prime and f prime in part B and g prime and f in part A. Because without that relationship, you don't really, nobody really knows how you know this. Only by showing that there is a connection between those things you will be able to justify this. Part C. Part C is asking that find the absolute minimum value and the absolute maximum value of g on the interval from -4 to 12, inclusive of the endpoints. Justify your answer. If you ever have a question on finding the minimum or absolute minimum and absolute maximum value, it always the easiest way to justify this would be by making a table of values. So the first thing we need to do is, if we look at G prime changes sign at -2. Remember, G prime is F. So we have a sign change here. This is our some kind of an extremum, and it also changes sign here. So we have -2 and 6 as our critical points. So we are going to make a table of values. But since it's an absolute minimum or maximum, we're going to need to make a table of values, and it's going to include the endpoint. So we're going to have x, we're going to have, g of x, right? G of x. We're going to have our left endpoint. We're going to have -2 as one of our critical values. 6 as, I'm sure I should say it's not a critical value, there are more critical points. This is a point where you have a minimum or maximum. 6 is another point, and we finally have 12. And what we need to do is evaluate our function g using that. I want to remind you that g is defined as the integral from 2 to x of f of t dt. So we're basically finding areas. So let's see what we have here. So first we're going to have to find the area going from 2 to -4. So remember, we're going backwards. There is a triangle here whose area will be 4 times 4 times a half, right? 4 times 4 times a half, that's 8, but it's going to be -8 because we're going backwards, and there's going to be a little bit more here. So we're actually going to end up with -4. Again, if I were to explain this here, the area of this triangle would be 4, the area of this triangle is 4, and the area of this triangle is 4. Right? Easy. 2 times 4 times a half. But here we start at 2. This is our starting point. When you go to the left, everything changes its sign. So even though it's above the x-axis, this is going to be negative. So -4, -8, and this one's going to turn out to be positive. +4, it's going to give you -4 total. At -2, we just will go -4, and it's going to give you a total of -8. For the reason I already explained. When you go from 2 to 6, this is going to be this triangle here. The region is above the x-axis, and you go to the right. This is in the correct direction. So this is going to be +8. And for 12, so we're going to have this triangle here and this triangle here. They're the same exact area, opposite in signs. They're going to cancel each other. And over here we're going to have this little tiny triangle. So when you go from 2 to 12, you're going to get +8, then -8, which will zero out, and then -4. So you're going to have a total of -4. Okay, so G of the maximum value of G of x on the interval from -4 to 12 is, now we're asking for the value, and I should say the absolute maximum value is going to happen here. It's the largest value. Remember, the table will justify. And the absolute minimum is going to be -8. Okay. Be very careful. These questions, when it's asking for value, that means you're looking for the value of the function, not the x, not where it happens, because our absolute maximum occurs at 6, but the value is 8. Alright, we have last part here, which is asking find intervals where g of x is negative. So where it's going to be negative? It's going to be negative wherever the integral will come out to be a negative value. And hopefully with doing this work, it will help you. If I look at this table, what I'm going to do is I'm going to look at this table because it's going to help us. and try to figure it out this way. So when we start at, remember our function starts at 2, so you go to the left. This is going to be negative, this is negative, this is going to be positive, but it's not enough to offset the negative. So on the interval from -4 to 2, g of x will be negative. -4 to 2. Then let's take a look. We can actually see from the table, from 2 to 6 we have a positive value. Let's see if it holds. Positive here, right? Then it's going to be negative here, but you have this area of 8, and all the way to 10 it's going to remain positive. It's only going to become 0 at 10 because that's when both areas are going to cancel each other. So then you're going to hit 10, and now you're going to get negative. So from 10 to 12 it's going to be negative. And 10 to 12. Okay, and that's all there is to it. Hope this helps.